Hello, hello. Good evening to my silent class. How are you? That's awesome. That's awesome. Do you know, guys, why I love this class? The reason is that it's silent. Like you guys just have to chat and then tell me how are you. Okay. Okay, so let's see if everyone is joined in. Okay. Zoo, Amy, Sai. Okay, most of you are joined in. Excellent. By the way, guys, I'm really impressed how the tests have gone so far. So it was awesome. I am really impressed by many students, especially Leo. Excellent job. The way you did it, awesome. Okay, guys, now let's start the class, okay? First of all, let's ask a little bit from you guys. And the first person who's gonna answer is Leo. Leo, can you tell me one thing that do you think that matter is okay, who is asking this? No, no, no. No, Nico, we have to see it. How does it work? Okay. Yes. Okay. Yes. So, Leo, can you tell me what matter is? Simply. I'm not going to make it complicated for you. Excellent. Perfect job. Excellent. Okay. Now, Fancy, can you tell me, like, if I take only the particles of argon, okay, argon, are they atom or molecules? Excellent job. Excellent job, atom. Okay, I could see this chat box. Okay. Okay, guys, now one other thing, if you're gonna comment the things which are not related to the chat box, then I really have to turn off you and put you away from this complex. So just make it clean, okay? Yes, just keep it clean. Okay. Okay, awesome. Awesome, guys. Now the next topic which we will have to study, it's about states of matter. Okay. Now I'm sure this topic is the most easiest because maybe you have learned about these things in grade 7 and 8. Okay, so in IGCSE, they're going to become easy. Remember, there are 3 states of matter. Okay, so which are solid, liquid, and gas. I'm sure you have heard about these a lot in your life. Okay. Now, the thing is this slide. Can you see this one? Okay, let me present. I forgot to present it. Okay. Can you see this one? And can all of you please answer me in yes and no about this table? Okay. Yes, go ahead, Sue, please. Good job. Perfect. Oh, I could see a lot of answers. Can you pour a gas? Yes or no? Oh, whoa, a lot of no's, a lot of yes. Okay, let's see. Can you stir it? Can you squash? Okay, now we have squish or squash. I don't know the pronunciation, but you got the meaning. Okay. Oh, yes or no's. Okay, let's see. Now, all of you have given the answer. Let's see. Now, please see. Oh, now I could see a lot of emojis, huh? With that blinded eyes. Okay. Perfect job. Now, the reason why I'm sure you have heard about how solids and liquids change, but in IGCSE, we will learn why solids change to liquids, how they change, what happened internally, why gases change to get, why liquid change to gases, and how does that happen. So we can really dig into the details how these process will happen in your this class. Okay, does it make sense to you? Please show me thumbs up in the chat box. Okay, excellent. Okay, now here is this process, how solid change to liquid, how liquid change to gases, and how this all alternative processes happen. We have special name for special processes. I'm sure that you have learned about it. Okay, please tell me yes and no if this picture is correct to you guys. Excellent job. So most of you have seen converting solid to liquids in your homes, liquid to gas in your homes, which is called melting and boiling. But have you ever seen a gas change to solid? Okay, this word is new for you. Excellent job. Oh, Leo, where did you saw that, huh? Come on, Leo. Okay, so gas and solid. Gas gonna change to solid, and the process is called deposition. Now, this process majorly you're gonna see in laboratories, but for sure we will gonna watch a video. But I will post a video on Google Classroom. Go and check it out so that you could know. and I'm going to ask you the questions from there. Okay, first of all, I want to see your reactions to see how gas changed to solid before I'm going to tell you. Okay. Yes. Okay. Perfect. Now, these are the processes. The solid converts to liquid. The process is called melting. Okay. Liquid converts to gas. The process is called boiling. The gas converts to solid. The process is called deposition. Okay. Remember, in IGCSE, we're going to learn how this happens. What happens inside. Okay. The internal picture of it. Okay. Now, here is the opposite thing. If a liquid changes to solid, all of you know it's freezing. Gas to liquid, all of you know it's condensation. I'm sure that you have learned this one in grade 8. But if a solid changed to gas directly, it's called sublimation. Have you all seen this process? Please tell me yes and no. No? Never in your life? But I will tell you have seen. Okay, all of you now, the people who live in Thailand, do you know Swenson's? I'm sure all of you are a big fan of it. Or any ice cream polo. Excellent, all of you love. But have you seen that sometimes when they like when they deliver a cake, an ice cream cake or an ice cream to your home, they have small ice blocks inside it. Okay, excellent. All of you are saying yes. So all of you have seen that thing. Those ice, have you noticed that once you pick up that ice is not an ordinary ice which is present in our refrigerators? Exactly. Okay, all of you say yes. Okay, so that's different. When you see that ice, it have a little smoke coming out of it. That is what solid converts to a gas. That's a special type of gas called as a dry ice. Okay. Yes, I mean a special type of ice is called dry ice. That process, if you see solid converts to gas, this is called sublimation. If someone doesn't have experience of seeing that, I am posting a video on Google Classroom. Go and check it out so you could see. Okay, so who is asking? Which flavor of ice cream do I like? Strawberry ice. Oh, yes, I know that I'm not in your gang. I don't like chocolate that much. Okay. In ice creams, in ice creams. Okay, now come back to the topic. So here are some changes of state. Solid to liquid, liquid to gas, gas to solid. These are some processes. Okay. So here, there are some videos you have to go and check it out. Now let's dig in it. So the first topic which we have done, it's called solids. Okay, if you see all the solids in the world, okay, if it is your either like if it's your laptop, your book, your pencil, or a paper, you're going to see that the particles inside them are arranged like this. Okay. Yes, this is the yes, actually, the story which here Leo is telling us. Yes, one day Miss Bintego and she dissected her laptop and she saw inside the solid particles were like that. Okay. Yes, so the solids are like this, but we have some special properties of it, and the properties are here. Let's study one by one. What does this word mean? Solids have strong forces of attraction between each molecule. Please tell me here in the chat box. Excellent job, Sue. Excellent job, Lily. Excellent job. Okay, so solids have a strong force of attraction. So this means that if you see the particles here, each of the particle will have a strong attraction to itself. They will attract so much. Why are they going to attract? Because they're so close together. Okay, so this is called solids have a great, good, strong force of attraction. Okay, between each molecule, they are held in a fixed position, and but can vibrate slowly. What does that mean? They doesn't move. If they cannot move, then how they could vibrate? Yes, exactly. So this statement, solid particles, the particles can move, but the movement is called vibration. Okay, they just vibrate slowly. They vibrate so slowly that they cannot exactly. They don't leave their position, but still, have you seen sometimes when, let's suppose I have given a punishment, okay, to Z and Leo that why they're doing great in my class. Exactly, this is the punishment which I'm doing. Okay, so Z and Leo said, "Oh, why, Miss Binte, have given us this punishment?" So Z said, like, Leo, we should do bad in the class. So what did they do? They just move back and forward, back and forward, back and forward, but they're not exactly, they're not leaving their position. Okay, this is the punishment. They're not leaving, but still they're talking. So this type of movement where you don't leave your position, but still you go back and forth, this is called vibration. So this happens same in the solids. Okay, so here they're going to move back and forth, but still they will be in this area. Okay, so this is what solids are. Okay, now they have a definite shape and volume. So their shape and volume doesn't change, okay, by itself. Okay, we have to do something to change their shape. So these are some properties of solid. Does it make sense to you guys? Okay, here's the brick, and I have given them position. So Liu and Z gonna stand here for doing great in my class. Okay. Okay, now here is a question. When heated, molecules gain energy, they vibrate more and more, or at faster. What does this word mean? Okay, you can have time. Please read it. Please read it. Okay, I'm getting a mixed answers. Let's dig it in so you could know what does that mean. Okay, so see here. Let's suppose I have okay. So let's suppose one day Leo went to the fridge, okay, as he's feeling lazy today. So what did he said? Okay, I should go to fridge, grab some ice, and drink a strawberry milkshake or something. Okay, so here is the ice particle he did. Okay, so as he grabbed it out, what did he do? Certainly, his brother comes in. And he said, "Hey, Leo, what are you doing? Why didn't you come to me? Or why did you wear my shirt? This, blah, 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 blah." He got angry. So Leo also got angry. So what did he do? He said, "Okay, stop. I don't want to drink any strawberry milkshake." So he put that ice on a stove. I hope that all of you know what stove is. Exactly, where your mom cook something. Excellent job. Okay, so he put the ice here. Once he put the ice, do you believe, as I told you, that inside ice, the particles are arranged like this? Okay, exactly, very close together. And he turned on. Okay, once he turned on the heat, what will happen? Do you agree that, first of all, the ice particles inside the ice, okay, let me draw them here. Okay, so here's your ice cube. The particles are like this. Okay, firstly, the particles were moving back and forth, back and forth, back and forth. This is a slow vibration. Okay, slowly vibrating, slow vibration was going on. Okay, but what happened once he provided the heat? Do you agree? Say yes or no in the chat that we are providing more energy to it, to the particles of ice? Exactly, yes. Okay, once we provide more energy to the particles, what will happen? That this vibration, now, first of all, they were vibrating at this speed. Now the particle is going to vibrate like that. Exactly, with more energy, a bigger vibration going to happen. Once that bigger vibration happens, what will happen that now the particles will leave their original position. So let's suppose if they were vibrating and they were still at this position, now they're going to move apart like this. Now, once they leave their fixed positions, do you think they are still in their solid form? Exactly. The answer is no. They have changed their form. Okay. Now they have changed from solid to liquid. So can you see what happening inside? Exactly. Everyone is like, wow, we didn't exactly. Wow. I could see a lot of wows now. Okay. Now, so from ice, from solid to liquid, we can change if we provide more heat, if we provide more energy to particles. Okay. They will vibrate really fast. Okay. And once they vibrate really fast, they will leave their fixed position and they will change their state of matter. Does it make sense to you? Excellent, marvelous job. Excellent job. So here is the case. So as that's why they're now, let's come back. When heated, molecules gain energy. Which molecules? The solid particles, okay? They vibrate more at faster rate and they no longer remain in their fixed position. This is how solids converge to liquid and the result change is liquid, okay? Exactly. Okay, now guys, here on your books, okay, remember the book which I have uploaded, okay, kindly go and check it out. Okay, so here there are water, solids, liquid, and gases, okay? So ice slowly changes to water when it puts in a warm place. We know that, and the process is called melting, okay? The thermometer shows 0 Celsius until all the ice has melted. So 0 Celsius is called its melting point. Now this thing, I want to ask you a question. If you put a thermometer, is this thermometer showing the temperature when all the ice converts to liquid? Or when it started? Please tell me yes or no. When all of it, okay. Oh, Leo, excellent. Good guess, huh? When it started. Okay, I have mixed answers here. I have range of answers here. Now see here. This, guys, this temperature, they are telling when Exactly. When the ice cube starts to melt, when it starts to melt, okay, that point is called as the melting point, okay? Exactly. When it's not like this when all the ice converted to liquid. No, then it will be melted point. No, melting point means the point where it starts to melt, okay? Exactly. So this is the first thing. Second one, when the water is heated, its temperature rises and some of its changes to water vapor. We know that you have seen when water boils, the steam come out. But can you guys tell me what's the difference between evaporation and boiling? Okay. I think it's a good guess. Okay, Zoo, what about you? Fancy. Lily. Okay. Okay, guys. Now, no. Okay, over here, all of you are incorrect. Surprisingly, why? Okay, now see here. Have you ever seen, like how does the water boil? If you haven't, kindly boil a water today at your home, you will see. Once you turn on the temperature, you will see after sometimes the steam will come out first. Have you noticed it? Exactly. That first of all, that steam is called water vapor. Okay, this point where first of all the steam comes out, this point is called evaporation. But after some times you will see that the bubbles and steam, both of them gonna come together. Exactly that bubbles, that sound, okay? This point is called as boiling when the water vapors and when bubbles come together, this point is called boiling, okay? But in evaporation, only water vapors, only the steam comes out. So this is the difference. These two are the difference, okay? So here is the short thing which I want to make sure. Now, what you guys have to do, kindly go and read the first 3 pages of your book. That's important. And my three students, okay? Lily, Zoo, and Fancy. Lily, Zoo, and Fancy. Please come up. So you guys will be the first one in the next class who can explain me the 3 pages, okay? And Lily, Fancy, and Zoo, if you have any questions, yes, ask me right now. Okay, now Lily, Zoo, and Fancy, you guys have to. You guys will explain me the 3 pages in my next class firstly. Okay. If the one who gonna explain the best, they will score 5 scores in their last exams. Okay. So let's suppose if out of 100 you got 95, okay, and you're 5 scores behind the full score, I'm gonna give you that 5 if you did best tomorrow. Oh, it's a cheating for all the other people. No, I have something for you guys. Now, Lily, Fancy, and Sue, you guys can ask 2 questions per person from your class. Any of the questions, but it should be related to the topic, okay? And if the person gives the correct answer, they will score 2 scores for the last exam. But if you didn't give the correct answer, your 2 scores going to be deducted. Okay, first you have sent me the heart emojis. Now you're sending me the crying emojis. That's awesome. I love it. Okay, guys, now I'm stopping here. I will see you in the next class. Bye bye. Sure, have a great day.